So it's great to be at the show. I look forward to this every year. There's not many occasions where you bring together all of the major players in the industry, all the folks looking to get in the industry, as well as customers and suppliers to the industry. So it's a great chance to network with people, find out what the newest technology is, get a sense for the industry and how things are going, and to talk to some customers who are interested in additive manufacturing, sometimes for the first time, and establish contacts for the future. So it's a great chance to get together for a few days and really check all of those boxes. The CEO panel was great this morning. First of all, it was extremely well organized and planned, so much appreciate that. It allowed everybody to be on point, ready to answer questions. It's an honor to be on stage with my fellow CEOs and leaders from the other companies in the industry. Everybody's got a bit different perspective, but you also see a lot of commonality. And it's a chance for everybody to participate in some of the key topics. How do you grow additive? Where's additive going in production? Sustainability aspects of additive. Many things like that can come out from a group conversation. So very well done, very well worth the time, and it was great to see the audience. So in the vein of how do we advance the additive manufacturing industry best and where it's going, where its needs are, economies of scale are very helpful. We all spend a very high percentage of our revenue on R&D and on sales, on SG&A. Because that's the state of our customer base right now. They need innovative products more than ever, both metal and polymer, and we need to be able to work with them on applications which drives the sales expanse, sales expertise, and sales cost. So scale helps all of that. It helps you reach people, and in servicing the installed base around the world as printing is adopted broadly. Is it required for success? I would say no. I think the industry will get there. Can it accelerate success? Potentially. But in the meantime, there's a number of areas where we can establish standards as an industry, for example. The way we communicate with customers around the performance of products, the specifications on equipment, how we measure ourselves. Very, very easy to establish standards and in that sense collaborate while still maintaining a competitive environment. So there's short-term and long-term benefits to this collaboration and consolidation. So AI is clearly exploding in the world, and there's two major areas, one of which is common to many companies, and that's back office functions, things that can be streamlined and enhanced, like customer service, some of the intelligence that you can put into becoming more efficient in the back office. But I would tell you a unique thing that we need as an industry that AI and machine learning can really add to, and that's how printers communicate with one another in a factory. So customers want to buy hundreds of printers and put them in a plant. So those machines need to be more intelligent than ever, self-calibrating, self-monitoring for producing the quality of part needed, and then ease or modification of setup. Also, traceability of products in many regulated industries, extremely important. AI and machine learning can help tremendously with that and really make AI advance into production environments more quickly. Talent, so the need for talent's never been greater. We're doing, I would say, three things. Number one, we have a very active internship program. Let me step back from that. There's a very aggressive move on the part of engineering activities at the college level, university level, to train young people in additive manufacturing, whether it's designed for additive manufacturing or the actual performance of additive manufacturing of parts. So the engineering education system has fully embraced additive manufacturing, which is extremely helpful in creating a larger talent pool. We bring those folks in aggressively in an internship program, hopefully for multiple years, where they can learn about our customer base, our technology, and then we often encourage them to even go to our customers, go do an internship at our customers, so you learn how, on the other side, how additive is being adopted. And then you attend workshops, anything from teaching the government what additive manufacturing is, which they often need to know that in more detail than in the past, to specific customer bases. So creating a talent pool to either receive our product or help design and manufacture our product, extremely important, and luckily there's a lot of good things going on in that area. So from a customer standpoint, what they need to adopt additive manufacturing more successfully, they're aware of this, they struggle sometimes to do it. When you get to startup companies or young companies, like some of the commercial rocketry companies and the electric vehicle companies, they've hired young engineers that have very few manufacturing paradigms. and they grew up in their college system with additive manufacturing, so they're fast to embrace the benefits, the uniqueness of additive manufacturing in a factory. That we're getting a lot of traction in those younger companies. In the large established companies, you see it happening in where the technology pull is heavy, like aerospace and defense, medical, where they need the technology very badly, they can benefit from it. The bureaucracies often slow them down. The need to pace their change slowly, the embedded paradigms. This is the way we've always manufactured it. They understand this, but those cultural changes take a long time. So I love working with younger companies, and some of them are quite big now, so they're fast adopters. The big companies that take more convincing, huge potential for us as an industry, and huge potential for them. They've got to get over their own inertia in order to adopt it. So with regard to medical in general, the areas that have migrated rapidly to 3D printing, dentistry and orthopedics, very well demonstrated. As we bring the cost down, very much more widespread. The next horizon now is regenerating human tissue. So creating what we call scaffolds made of human tissue to embed in the body so the body can heal itself, whether it's arteries and veins, it's bones, or it's even organs. One of our most exciting projects, which we do in partnership with United Therapeutics, is the printing of lungs, human lungs. We are within years, not decades, but years of having those lungs in a human being for medical trials and then final adoption, which will really change the world for thousands, if not tens of thousands of people around the world that are waiting for transplants. So whether it's recovering from trauma, or it's healing a long-term illness, or it's replacing organs, 3D printing is revolutionizing healthcare from orthopedics to regenerating tissue. It's great to be a part of that. I view us as one of the leaders, and we're fully committed to making that happen. So to do it successfully, it requires the fundamental three areas. You've got to advance the materials in order to print human tissue. It's got to be human compatible materials. You have to print them at precisions never before attained, at speeds never before attained, to print something as complex as a lung, for example. And then you have to have the software to control it in the most reliable way humanly possible, so that you eliminate any source of defects while you're printing this object, which can often take days or even months to print. So very long runs, very high precision, high speed. So we have to bring all three of those elements together. We've invested an enormous amount of money, as has our partner, in making that happen. And we're now educating the FDA on the technology, and we're going to work through that whole regulatory process to get into trials. Very, very exciting. So collaboration at these industry events, incredibly important. We find customers around the world are giving us all the same feedback in terms of what it takes. They may emphasize one point more than another, but by getting together and comparing notes on how do we advance the industry and what areas can we actually collaborate in, openly, where competitive feelings are set aside and we can make it good. For example, sustainability. How do we better use the powder that we use for making parts in a recyclable, sustainable manner? How do we tackle applications that are for green energy, for example? How do we tackle those from our different technology perspectives? Those are all areas of fruitful thought. And as I mentioned, standardization of metrics. How should a customer measure our products and adapt them to their environment? Excellent areas for collaboration. I would also offer the educational system. Training young people, no matter if it's at our company or our competitor companies, in additive and how to use additive, whether they end up at our place or a customer site or a competitor, it will advance the entire industry. So collaborating at the university level, also extremely important.